Hello viewers, welcome back to part 2 of the DVW-500P Sony Digital Betacam Teardown that I started. So covered all of the sort of main sort of electronics of the unit in the previous video, and we're going to look at all the mechanics in this section. So I've got myself a coffee, I've got myself some cheesy puffs, keep me going because this might take a while. And right, so what we'll do first, we'll just have a look around the whole thing, look at all the major components, and then we'll start taking bits off. So right at the front here, we've got the two supply and take up motors. Those actually drive the cassette. We've got a mechanical arrangement here to change the cassette size. So this will, as you insert a cassette, these will move into position depending on the size of the cassette. And yeah, the whole motor assembly and the brake and everything is all on a movable rail thing here. So all the motors and everything moves as one. Now, I should also mention that these will be quite sophisticated servo motors because everything has to run at certain speeds to generate the right tape tensions and all of that sort of good stuff. So these will be quite sophisticated motors. If we turn it round a little bit, we can take a look at the side. Just here we have the tape tension sensor. So this arm here, the tape runs around it, and it's quite finely balanced, and basically it just monitors the tape tension, and that'll allow the system to feed back and then servo the supply reel and to alter the speed of it to keep the tape tension right. So coming a bit further around, we've got a couple of wires running up to a solenoid up here. That is the video head cleaning system, so that is activated as and when it's needed, and you'll be able to see that a little bit later on because it's a bit buried away down in there. We've got the Capstan, and the pinch roller would normally be around here when the tape's loaded, and there's a big solenoid just here which actually applies pressure to the pinch roller onto the capstan to capture the tape. Right at the back here we've got the drive motor for the tape threading mechanism. Now what I've actually done here, I was actually going to try and run this, but it turns out that this gear is actually broken, and it wasn't really going to work. So what I've done, I've actually taken out one of the cogs somewhere. Where have I got it? It was just this one here, so I can actually move this manually by hand without having to fiddle around with the motor. So I'll show you that operating in just a moment, but that's the motor that operates the actual tape threading assembly. Okay, coming a bit further around, we've got these connections here. Now these are for the audio heads, and I think the normal time code is actually on these heads as well. So you've got audio arrays and record heads just there. Loads and loads of little rollers. You'll see more of that when I look at the actual tape threading. Just around here we've got another tension sensor arm. That's going to be for the return tension. So as the tape comes back, this will monitor the tension on the take-up spool. We've got a couple of boards and stuff down in here. There you go, that's a bit better view for you. We've got a board just here. Now this is going to be for the dynamic tracking. I'm pretty certain that Betacam SP machine had a similar arrangement, that the dynamic tracking stuff was hung over the top. So we move a little bit further around onto this side. We have more parts for the tape threading and tape alignment. We've got another cleaning wheel just there. We've got tape detection sensors, so they'll actually detect when the tape is actually passing nearby. And we have this little arrangement here, which is quite neat. I think this has actually been added to allow you to manually unthread the machine without wrecking your tape. I don't recall seeing anything like that on the old Betacam SP machine. So I think what you'd be able to do is actually unthread this manually and actually use this to, you actually pull this little lever and you've got a little metal wire which comes to this assembly and actually allows you to operate the tape spool. So obviously for taking up the slack as it unthreads out of the drum. And we're back around onto the front, so you can see most of the tape threading parts, lots of guide rollers and things like that. That's the pinch roller, that's a guide, that's this, which is part of the tape tension sensor. This one and this one are the actual two arms which pull the tape out of the cassette. You'll see that in a minute when I demonstrate it. And just up here we have the fully raised head and the control head, which is just there, and then another guide roller, and we've got another tape sensor, and this, I believe this little object here is a tape cleaner. I don't recall seeing one of those on the analog format either, so that is some kind of device which actually cleans the tape before it actually gets to the drum, which is a neat idea. So I've already read up in the service manual that this is part of the motor drive control board, so there's loads of power transistors and probably MOSFETs and all sorts of stuff going on there to switch and control motors and do all sorts of mechanical things that are needed. So lots of ribbon cables running out to those go to the, that's the supply motor, that's the take-up motor. These are probably the drum and capstan drive control signal things. This actually also opens, because this would have been accessible from the bottom of the machine. If you remember part one where I actually took the bottom panel off, you can actually get access to this. So this opens up and gives you access to the drum motor and the capstan motor and this box of electronics. This, I'm not really sure what this board is, but I'm going to hazard a guess that it might be something to do with the high voltage used for the dynamic tracking. It also has DT34 on it just there, so I think that's part of the dynamic tracking. A little board here, just notice this weird thing here, and it's a dew sensor. So yeah, we've got a little component there. So obviously, yeah, if you take this from a cold environment and then move it into a warm one, you've got a risk of condensation and stuff like that. And there's the actual sensor for it. I believe there was one on the analog system as well, but yeah, interesting to see it here as well. So I've got myself a cassette. Now, the problem I'm going to have, I'll just feed that back, is if I place this down where it should go, I need to open the door. Place this down roughly there. Now the problem is all the pins and everything make it want to ping back up out of place, so I'm just going to get some tape this down, which will make things a little bit easier. Right, so I've got this all set up. You might not be able to see the tape straight away because it's literally just tucked in there, and of course it's black, it's very hard to see, but you should be able to see it once the tape starts to be extracted out. And I'll just be moving this manually with my hand. So as I move this round, you'll see those two arms that I mentioned before pick up the tape. So the tape tensioner, one, which is this one here, starting to pull that way, and this one is starting to pull roughly towards us. And as it does so, it starts to wrap. It wraps it around the control and the fully raised head, which are just over there. And this arm here is starting to pull the tape out to start threading it round the actual drum. So it starts to come along here. Now this roller here is going to take up the tape as this bar moves out of the way. Grab the tape, and this bar then stays out of the way until everything's gone past. It uses the pinch roller as a guide roller there, and we go further and further round. And then it locks into place. So there's a slightly different view on the fully threaded tape mechanism, and of course the pinch roller here is literally just on a solenoid. So the tape comes all the way around the head, past the audio and timecode heads, pinch roller back through, and then all the way back around here. Notice there is actually this other arm here which is keeping an eye on the tension of the return tape down to the take-up spool. And you can see down in here the tape tensioner just here. So this will move about by maybe 4 or 5 millimeters, depending on the tension of the tape, which will feed back to the sensor that's in the arm there. So we can have a look at this in a little bit more detail. Some of the bits here that I find particularly intriguing is this arm here, which is the one that draws the tape out on the take-up side. So I love the action on this, the design of all these little cam wheels and stuff, that it is all actuated off this one ring. It's awesome. It's got a tiny little roller just on the bottom here, which first hits this, which is pushed that way. Because of the arrangement of this, it wants to move that direction, which then means it passes around the back of that bit of plastic. But then as it starts moving away it's moving in an arc, and then it ends up goes around the back and then pushes on this other bit of plastic which is just in here. So it pushes on it there, pushes it out of the way, and then threads it round this roller here. And the final little bit of flair is as it pushes up here, it actually gets a little tilt on it. I found that that's beautiful, absolutely beautiful. So if I show you the audio heads, which are just here and here, these also get a clean. Now the interesting thing is, where is the thing that does the cleaning? Well, what actually happens is when the cassette is actually loaded or unloaded, this little roller here, which is attached to the threading wheel, this comes down, follows this piece of plastic here, and that guides it down onto the audio heads. And what it actually does as well, it mates up with this little toothed arrangement here, which mates in with the bottom of the roller and actually makes the roller spin backwards as it moves past the head, and then moves out the way. And then the final little touch is down here on the capstan, and it just dips in and makes a little contact with the capstan. I would imagine the capstan will be running at that point, so it'll probably just spin up the capstan a little bit just as the cleaning head gives it a touch, and then it moves out the way and it all locks into position. Absolutely beautiful. So as you can see, I've had a bit of a tidy up. I've put back on all the bits that were on the actual drum and video head assembly, just so you can get a better idea on the on this part of the teardown. Really, it was just to reset everything back. I've also got here my the remains of the head and drum assembly from the DVW-500, which was the analog Betacam SP machine. So I've got this here just for reference. There's quite a bit missing off this, to be honest. The motor's gone off the bottom and the heads are missing, and but it should give us a bit of a reference point when we have a look at this Digi-Beta head assembly. So one of the first things you can spot is the difference in the drum. On the BVW, the analog format, the whole of the head drum was spinning with the heads embedded inside it. Now what they've done on the Digi-Beta is this part is actually fixed, it doesn't move, and the heads are actually just on a small rotating part in the centre there. Exactly why they've done that, I'm not sure. I would say it's probably reduced tape wear. The less of the metal drum that is actually on touching the tape, then it's going to wear the tape less. So that is probably the reason for that. Another thing I've noticed on here, I thought there was actually some imperfections on the actual drum, but no, they are not. I'm pretty sure these are some kind of markers. They are perfectly in line to where the tape was going, and they actually have a particular shape to them as well. So I'm going to hazard a guess they might be sort of an approximate wear indicator, maybe. I'm not entirely sure. Now, because we have this fixed part of the drum, there's also this frame assembly which holds it in place, effectively floating over the top of the actual heads. Now, as you saw before, we've got the covers and everything that I put back on. Previously I mentioned about this small little filter. Now, you kind of wonder, well, why do they need a filter? Surely there's not going to be that much air moving about. But then if you start to think about it, This is all sealed, and with this part spinning, this is actually going to effectively be drawing air through the top, and then there will be actually air coming out of the holes where the heads protrude out because of the centrifugal force of the actual drum spinning. It's going to throw the air out and draw it in from the top, so that's probably why they've got a filter in the top there. So I'm just going to disassemble this again now. So I've decided to lay it all out, and we can look at each part in turn. So it's pretty much laid out in terms of the order that it comes apart. So you've got the top here, we've got the metal cover ring, we've got the connections for the dynamic tracking, plastic cover, we've got the 2 circuit boards for the dynamic tracking, I think. Certainly that one is. We've got the video heads themselves, and if we scroll pan back over here, we've got this PCB which takes the video head information down onto this spindle. We've got the rotary transformer, that's the inner core, and we have the outer one in the actual body of the drum, and then we have the motor assembly just mounted on a PCB, mounting boss, and finally the permanent magnet for the motor, which does actually have a little balancing weight on the back. So let's just rearrange this a little bit just to get the less important bits out of the way, so give us a little bit more room to look at the more interesting parts. So I think what we'll do first is have a look at the dynamic tracking, because we can just get these 2 parts out of the way. So this is the finger, I call it a finger assembly, which is a double-sided finger arrangement which transfers the dynamic tracking control onto this circuit board, which then transfers it via a flat flex to the actual tracking heads. So that just mounts in there and just makes contact with some pogo pins. So that's pretty much the dynamic tracking, apart from the actual section which is built into the heads themselves. So let's put that to one side. Now if we look at the heads, underneath here we have, okay, so under the main head drum, we have 2 heads here that have dynamic tracking. Those are playback heads. Now, the reason why there's a space here is because there is potentially for another pair of read heads with dynamic tracking, and those are for the A500 player and recorder that can that also has the backwards compatibility with the old analog format. So I'd originally thought that they would have read the analog video portion using the same heads, but nope, if you have the analog playback option installed, then the heads are different as well, and there's a dedicated set of heads to read the old analog format with a separate set of digital ones just for the digital. And that is also why we are missing two connectors on here, because this is the 500, which is digital only and can't play back analog, so obviously they're not fitted because they're not needed. Presumably this arrangement would have been twice as high or have more contacts on for the one that has 4 dynamic tracking heads. So if we come back to the main head assembly, we have the dynamic tracking playback heads, which are just here. Then we have these 3 heads here. Now these are the record heads, and then these 2 separate pairs are the confidence playback heads. What the confidence is used for is an entirely separate playback head system to allow you to view what you've literally just recorded. So as the record heads have made the actual recording, the confidence heads will just read it straight back. So to try and explain that a little bit better, if for example we are inserting some video frames onto an existing recording, like an insert edit for example, with the drum spinning this way, we'd have this read head would read the current signal that's actually on the tape. It would then get erased by this head here, which is the erase head. These are the 2 record heads, and then if you've got confidence playback turned on, then the playback heads will then read the signal back just to confirm it all has been recorded onto the tape. And this again happens on the other half as well, because it's completely symmetrical. Now, one of the strange things that I hadn't really realised until I've read some information about this is it takes 1.5 revolutions to actually record a full frame of digital video, unlike the old analog format where it could actually have an entire 2 fields of video in 1 revolution of the drum. So it meant you had the entire picture there, always permanently read by one of the heads. But in digital Betacam that appears not to be the case. It's actually 1.5 revolutions, so that means the tape will have to advance or rewind to capture a full pair of fields. So presumably the processing on the circuit board has a frame store, and it just reads it all in and then builds the picture, and then that becomes like a freeze frame. And of course if the tape is actually moving, then it doesn't really matter. So there is the actual video head itself, taken out of the drum. There was a couple of very, very small little shims. I suspect there's probably all sorts of alignment and stuff to do if you change these to get the positioning spot on. There's probably different size shims that you'd fit in and all sorts. But you can see there the heads at the front mounted on a long bar, and that is mounted on a triangular piece of piezoelectric material. You can see one connection at the top and one going to the bottom, so it'll be able to steer it up and down over its sort of natural position. And the actual connection to the video heads is actually on the base. So you've got 4 connections there, which connect through to some pogo pins on the actual drum. It's also interesting to see there's some actual handwritten marks there written on it, so it's obviously very, very small production numbers. Everything's sort of hand finished, crazy expensive stuff. And here you can see that shim that I just mentioned. So there's one on each side. So that's the heads dealt with. If we look at this board here, which is attached to the bottom of the spinning head assembly, we've got up to 4 connections through to the dynamic tracking playback heads, dynamic tracking playback heads. So these mate together like that with pogo pins that actually make contact with the actual heads, and that transfers the signal down onto this circuit board, and then from here it then gets transferred onto this rotary transformer. You can see each of the outputs there gets fed into one of these coils. These then mate up with the outer core of the transformer down in here, so that would slide in there, and this part would be still, of course, and this would be spinning, and that would then transfer the signal onto the coils on the outer part, and then transferred through this little circuit board to the connections underneath. And the actual transformer itself is held on this spindle, so this would have just slid on here. There's a couple of little mounting locating points where it just fits on there, and this was actually bonded on here with a bit of epoxy. I broke that so I could actually get it off, so that would have been on there. The other thing that is really nice is the attention to detail in alignment. It seems really difficult to mix any of the positions up. You know, if you're like 90 degrees out or 180 degrees out, there seems to have they've made like little adjustments just to make it so it doesn't fit the wrong way. So I think that probably concludes this teardown. It's been an absolutely beautiful bit of engineering. You can always trust Sony to come up with something epic, and yeah, this is something special. I shudder to think how many talented engineers worked on this and actually perfected all these little bits to make it all come together into a machine that was actually extremely reliable and produced fantastic results, and formed part of the backbone of digital recording back in the 1990s. So to those Sony engineers, I salute you. Nice job. If you found this video interesting, give it a thumbs up, give it a share, all that sort of good stuff. Comments are always welcome down in the comments section. If you want to throw some coins into the hat for future teardowns, you can head over to my Patreon, where I'd welcome anything there. The more funds that I have, the more interesting stuff like this I can actually buy and take apart. And thanks again to my sponsor, PCBWay. Thank you very much for the support that they're giving, and look forward to a future video. I've already ordered some PCBs from them, so I will be waiting for those to arrive. Okay, thanks very much everyone. I'll see you on the next video. Bye for now.